Okay, it's Coach Williams here again, and we are going to go over 7.8 and 7.9 notes. We're still dealing with factoring, and we're going to look at some patterns that we hopefully will begin to notice as we continue along. One of those is going to be the difference in two squares. Obviously, we call this the difference of squares sometimes, just in general, shorten it down. This is a difference of two squares pattern. You'll notice that on this first section here, numerically, representatively by variables a squared minus b squared. If you were to square this is the same thing as these two factors here, multiplied together. If you were to take and multiply these together, not square, but multiply these together, you'd end up with a times a and a times b, so we'd have a squared. A times b would be a negative ab. The negative sign makes them negative. Then you multiply this b times both terms, just like we would, FOIL this or distribute everything through. So then we'd have a plus ba, or ab is the same thing. And then b times the negative b would be a negative b squared. If you'll notice, this middle two terms that we always say we can combine in some form of fashion, in this case, they just cancel each other out because you have a negative ab and a positive ab. So anytime you have a plus version and a minus version of two binomials, this is called the difference of two squares. And so one's adding, one's subtracting. And so you end up with a squared minus b squared. And that's where we see that form, when we have this plus and minus. If we have numerically, we add some numbers in here. We got x squared minus 9. Well, it's the same thing as x squared minus the square root of this. Don't worry about the negative sign. The square root of that. And so that's the same thing as 3 squared. And then once we get to this point, we take out the x, we take out the 3, and we just create two binomials, one with a plus and one with a minus. You will see that as we move along into the examples. But this is called the difference of squares, or difference of two squares. And we're going to need to recognize this when we're doing some of our factoring with polynomials, just to make things a little faster for us. It'll help us, find the factors of some equations that we might otherwise get a little frustrated not being able to get to that answer. So let's move along and look at a few practice problems here. All right, so number 1. We have a perfect square minus a perfect square. And anytime we have that scenario, like we have right up here, we said, we can take the square root of these two. And so the square root of s is going to be, square root of s squared is going to be s. So this is going to be s plus something, s minus something, and that something is the square root of 49. The square root of 49 is 7. I'll show you how to do that in the calculator in just a second. But we're going to have s plus 7 and s minus 7. Does that make sense? What we're doing there, we're taking, this is a difference of two squares. We have a plus version and a minus version of s and 7. If we multiply those together, again, that middle term, I would have a positive 7s and a negative 7s, and they just cancel. So it just leaves me with the square of this s minus the square of the 7, s squared minus 49. Now, if you get to some larger numbers that you may not know the square root of just off the top of your head, and you need to use the calculator, we can do that with the calculator fairly easily. We can use the square root function on the calculator, which is just simply the second button and the square button. If you'll notice the little blue version, the second or the alternate key for this is the square root symbol. So if I hit second x squared, it gives me the square root sign. I can put whatever number I'm trying to find the square root of, in this case 49, and it would give me 7. So that can help you get the last term in your binomials here when you're finding these perfect squares, or to find out if it is a perfect square or not. So let's move on to number 2. I have a perfect square in t, because I have t squared. Is 81 a perfect square? And it is. 9 times 9 is 81. And so this is just going to be, very easily, because we're recognizing this pattern, this is going to be t plus 9 and t minus 9. Okay, so we have that for number 1, that for number 2, And number 3 is not going to be any different. They're just reversed order. This is still a squared minus b squared, so we just leave them in that same order. What's the square root of 16? 4. And so we'll have 4 plus something and 4 minus something. Well, the square root of x squared is just x. So x goes in that something spot, we'll call it. Okay? Pretty easy stuff. Pretty easy stuff. Okay? Let's move on to number 4. On number 4, we have 4g squared minus 25. Is 4g squared a perfect square? No. Yes, it is. This is 2g. 2g times 2g would give me 4g squared. Is 25 a perfect square? Yes. 5 times 5. 5 times 5 is 25. So we will have 2g plus 5 and 2g minus 5. Those are our two factors of this difference of squares. Okay. On number 5, is 36h squared a perfect square? Yes. And what is that? What times what equals 36? 6. 6. So we'll have 6h, because they're 8 squared. We'll have to take the square root of that too. That as well. 6h plus, what is the square root of 121? 11. So we have 6h plus 11 and 6h minus 11. And there we have our factored form of that difference of squares. All right, number 6. Number 6, what is the perfect square of 81? We already said that was 9. So we're going to have 9 plus something, 9 minus something. And what is the square root of 49k squared? 7 and k, right? 7k. Because 7k times 7k would give me 49k squared. So we'll have a 7k there, and we'll have a 7k there. All right. Now that we've learned how to factor these perfect squares, it's going to ask us to apply that principle in solving. So if we're going to solve this, we have to factor it first and then set each factor equal to 0. So that's what we're going to do on 7 and 8. Okay, so what is the factored form of x squared minus 144? Yes, there's going to be, this is 12 and that's x. So we're going to have x plus 12, x minus 12. And we set that equal to 0. And now we need to take each factor and set them equal to 0 to solve for x and find the solutions or the zeros of this equation or polynomial. So we're going to have x plus 12 equal to 0 and x minus 12 equals 0. It's going to be pretty simple to find out what this is going to be. We'll do the steps here at first, but after that we're probably going to see it's just going to be the positive and the negative version of 12. So if I took and subtracted 12 from both sides, and if I took and added 12 to both sides, that would help me get rid of those. And so x is going to equal a negative 12, or x is going to equal a positive 12, and those would be my solutions to number 7. And again, like I said, you're going to begin to pick up on the fact that it's just going to be a positive and a negative version on your answer of the same answer, basically. All right, number 8, we have to get it in standard form first. We need to get the 49 on the left with the 9y squared and then set this all equal to 0. So if I move the 49 across, that means I'm going to end up with 9y squared minus 49 equal to 0. So now I can take and use my difference of squares pattern to break this apart into the two factors. What's the square root of 9y squared? 3y, and it's going to be plus something, and then 3y minus something, right? What's the square root of 49? We already determined that up top was 7, so we'll have 3y plus 7 and 3y minus 7. Now at this point, I need to set these equal to 0 because this whole thing is supposed to be equal to 0. So I'm going to set each factor equal to 0 and solve for y. So 3y plus 7 is going to equal 0, or 3y minus 7 is going to equal 0. I'll move the 7 across, and I'll move the 7 across over here, which makes it positive. Okay, so then we'll have 3y equals a negative 7, and we'll have 3y equals a positive 7. I'll then have to divide by 3 to get y by itself. So I'll divide by 3, divide by 3. The 3's will become a 1 here. That becomes a 1. And so y is going to equal a negative 7 over 3, or y is going to equal a positive 7 over 3. Okay? And that is the solution for number 8. Okay, and then that pretty much is difference of squares. Let's move on to 7.9 notes. And we're just going to look at some core concepts on factoring, but we're going to talk a little bit more about factoring by grouping. All right, so to factor a polynomial with 4 terms, group the terms into pairs. Factor the GCF out of each pair of terms. Look for and factor out the common binomial factor. This process is called factoring by grouping, and we'll see that in just a minute. But let's look at some of our factoring steps that we've done before. Factor out, number 1, the greatest common monomial factor. In this case, we could take a 3x out of both of these, and it would become 3x times x plus 2. All right, and then the next one says look for a difference of 2 squares, so we or a perfect square. In this case, this is a perfect square because x plus 2 times x plus 2 equals this. And the way you look for those perfect squares is, does the square root of the last term multiplied by 2 equal the middle term? In other words, can I take the square root of 4, double it, and it be the middle term? And in this case, that's the case. So it's just x plus 2 squared. Another way we can do the factoring is factor trinomial of the form ax squared plus bx plus c into a product of binomial factors. We've done that before using the x method. Remember that? We put in our a times c and b, and then our 2 factors on the side that multiply to be the top and add to be the bottom. So we've done that version as well. And then the last option here was one we're going to talk about today, which is factoring polynomial with 4 terms by grouping. And basically what they've done is they've said, okay, well, can I factor something out of the first group, and can I factor something out of the second group, and then can I pull those factors apart? And we'll show you how to do that on this first one. And here they were able to pull out x squared plus 1 times x minus 4, and I'll show you how that's done. On number 1, on the extra practice, what could I pull out of, and I'm just going to break this apart into 2 factors, or 2 groups, 2 groups. So in this group, can I factor something out of b cubed minus 4b squared? Is there a common factor in both of those terms? And there is. It's a b squared. I can pull a b squared out of both of those terms. Does everybody see that? I have b times b times b in this first factor minus 4 times b, right? That's that first one. I could pull a b squared out and a b squared out, and that leaves me with what? b minus 4. That's the only thing left is this middle part here, b minus 4. In the second one, there's nothing really to factor out. We just have plus b minus 4. But if you think about it, if I group that together like this, can I multiply that whole thing times 1? And it just leaves it the same, right? It doesn't change anything. Now, can I factor out something that's in both of these terms right here? And I can. I can factor out the b minus 4. So I'm going to pull out this b minus 4 out of both of those terms. So I pull it out to the front. I've got b minus 4. What's left? b squared plus 1. So I've got b squared plus 1 remaining, and that is my factoring by grouping. Okay? So you'll basically factor once and then try to factor a binomial out of that. Alright, so let's look at number 2. Can I take in this one and find groups here? I've got some common things in the first part, and I've got some common things in the second part. Okay? What's common in the first part on number 2? What letter do you see in both of them? A, right? You see an A in both of these. So we can pull an A out, and if I pull the A out, what's left? C plus D. Okay, C plus D. In the second group, okay, put a little plus sign here for now. In the second group, what can I pull out that's in both of these? A B. So I'm going to have a B, and what's left if I pull the two B's out? C plus D. Now we're looking and we see that there's a C plus D here, and there's a C plus D there. So I can pull that C plus D out of both terms, and now what's left? A plus B. And that completes factoring by grouping on number 2. We staying up to speed here. We're kind of getting it, hopefully. All right, let's work a few more problems here. We've got on number 3, we can divide this up into groups here. On the first group, what's common? D. D is the only thing common on that first one. And really, yeah, we can still. So we have D times, and then what's left? To pull a D out of this one, I only have one D left. I pull a D out of that, I have a C left. And then what's common in the next one? 2. So I pull a 2 out of both of those. Oops, sorry. I end up with a D plus C. And then, at this point, I look and I see I've got a D plus C in both of those terms. So I can factor that out. So I have D plus C times whatever's left, D plus 2. Alright, that is my factored form of number 3. Alright, number 4. Number 4 gives us a little bit of a challenge. We have to look right here. Okay, look right there, the negative sign. If we break this into 2 parts, we have to be careful how we handle that negative sign. Okay, all right. So let's watch and see what happens. I'm going to break this into this section here, and break it into that section right there. In the first section, what can I pull out that's a greatest common factor of 12a cubed and 2a squared? Can I pull the 2a squared out of both of them? Sure. This is the same thing as 6a times 2a squared. Right? Isn't that 12a cubed? And this is the same thing as 2a squared. We know that already. So I can pull a 2a squared out of both of those, and that's the same thing as 1 times that, so we can always leave a 1 there. Don't just make it go away completely. When you divide anything by itself, it's always a 1. So I saw that happen on some of our quizzes. When we divided one of them out, we just let it go away. It doesn't go away, it becomes a 1. So if I factor this 2a squared out of the first group, I'm going to be left with a 6a. So we took 2 of the a's away from the 3, so we only have 1 left. And then I have plus 1, because 2a squared divided by 2a squared is positive 1. Now in the next part, this is where we have to be cautious how we do this. The next part, we have a negative 30a minus 5. It's minus and minus, so let's pull out a negative so we can make both of those positive, right, whenever we create our factor here. What can we pull out of both of these that's negative? How about the negative 5? I can pull a negative 5 out of here, and I can pull a negative 5 out of the 30. So let's take out a negative 5. Okay? And when I take a negative 5 away from this, so I'm going to say negative 30a divided by negative 5 gives me a positive, right? Negative divided by negative is positive, positive 6a. And then if I divide negative 5 by negative 5, I have a positive 1. Anything over itself is 1. All right, and then you'll notice I've got two common factors in both terms here. I can pull the 6a plus 1 out of both of them. 6a plus 1. And then what I have left from both terms is going to be 2a squared minus 5. Okay? And that is number 4 factored. Number 4 factored. Okay, let's turn the page. On number 8, we can take this first group. Again, this one's got a negative, so pay attention to that. Always look when there's a negative separating your groups. All right, so this one we can take an s out of this first group. So we're going to have s times 8s squared plus, what's s divided by s? 1. And then we've got a negative and a negative. Let's pull a negative 8 out of both of those. We can take an 8 out of both of them for sure, but let's take a negative 8 out of both of those. So we'll have a minus 8, and that's going to leave me with 8s squared. 8 times 8 is 64, right? And then I'll have a plus 1, because a negative 8 divided by negative 8 gives me a positive 1. And then we should notice our common factor or common binomial in both of these terms. We'll pull that out. 8s squared plus 1. Those are gone, so now the only thing left is s minus 8. Is this becoming a little easier as we move along? Okay, let's look at number 6. First group I've got, I can take out what from that group? What's in both of those? I can't take a 5 out of both of them. I can't take 6 out of both of them. There's t's in both of them, but how many of them can we take out? 2 of them, right. So I have t squared that I can take out of the first one, which will leave me with 5t. I can take t squared out of the 6t squared, which just leaves me with 6. All right, that's the first group. What about the second group? Well, there's 5t plus 6 is all that's left. So we have 5t plus 6, but remember that there's always a 1 out there in front. So whenever I take out my common binomial of 5t plus 6, what's left? I have t squared plus 1. And there's my factored form of number 6. Okay, now we're going to get a little more work doing all of our factoring that we've learned. So we're going to factor completely, this thing says. So we definitely have to get this down to all the little factors or the pieces that will combine to make this product of 4c cubed minus 4c on number 7. First, I know I can pull out something out of both of these before I even get started. What can I pull out of both of these terms? I can pull out a 4, and I can pull out what? A c. I can pull out 1c at least. So I've got 4 and c, and what do I have left? I have c squared, and then if I take 4c out here, I've got negative 1. Now, we might look at this and say, oh, okay, cool, we can stop at this point, but if you think about it, this c minus 1, is c a perfect square? C squared a perfect square? Yes. Is 1 a perfect square? Yes. 1 times 1 is 1. And we've got a negative sign between them, so this is a difference of squares, or difference of 2 squares. So I can take the square of the first one, add it to the square of the second one, and then I'm going to multiply that times the square of the first one minus the square of the second one. And don't forget that you have your 4c out front. So my completely factored form should be 4c times, in parentheses, c plus 1 times, in parentheses, c minus 1. Okay, that should be my factored form completely. All right, let's look at number 8. Can I pull something out of both of them before I get started? Yes. Numerically, what number can I pull out of both? 25. So let's start with that. We got 25. Now, with variables in mind, how many of the x's can I pull out of both? 2. So I'm going to have 25x squared. And then that leaves me with this first term. When I divide 25 out of it, I get 4. And divide the x squared out, I get x squared. When I divide this by 25x squared, I get minus 1. Okay? And once again, we may think we're done, but that's a perfect square, and so is 1. And so we'll bring our 25x down, that 25x squared down. And we'll take the square root of this. It's the square root of 4x squared. 2x, yes, 2x. I'm going to add the square of the last one, which is just 1. I'm going to take 2x and minus the square of the last one, which is still 1. Now the question has been asked, Coach, does it matter if these start with a minus and then go to the plus? And it doesn't really matter. As long as one's plus and one's minus, the minus may come first or the plus may come first. It doesn't really matter. Multiplication is once again commutative, so the order doesn't matter here as long as you have a plus version and a minus version of that binomial. Okay, number 9. I can't factor any one thing out of all of this. So what are we going to have to resort to get the two binomial factors on number 9? Does anybody remember what we may have to do? What does this ring a bell? Oh yeah, Coach. Okay, so I'm going to have to locate values for A, B, and C. So what is the value for A? 2. What's the value for B?
3.
And the value for C?
2.
Negative 2. Yes, negative 2. All right, and then remember that in the top we have A times C. So 2 times the negative 2 is a negative 4. On the bottom we always have B. B always is in the bottom, so we have a positive 3. And now, because this is negative, we're looking for the difference that will become a 3. We multiply two things together to get negative 4, but the difference should be a positive 3. So the factors of 4 are 1 and 4 and 2 and 2. Well, the difference of 2 and 2 is 0. The difference of 1 and 4 is 3. So we have 1 and 4. And remember that the sign of the bottom has to match the sign of the bigger of your two factors. So that's positive. That's positive. This one has to be negative in order to produce a negative product on the top, right? All right, so now, and then don't forget this part. When I have A not equal to 1, when it does not equal 1, then I have to put my factors over A when I create my binomial factors here. So I'm going to have, watch this, I'm going to have A minus 1 over 2. I have to put that over A. And then I'm going to have A plus 4 over 2. Okay? Remember, when this is not A, we have to put the factors over A. I mean, when A is not 1, we have to put the factors over A that we get from our X method here, okay? All right, so we reduce these fractions as much as we can, or simplify them as much as we can. 1/2 is as far as it'll go, but 4 over 2 we can reduce to a 2. All right, so we need to now, that's reduced, so we don't have to worry about that fraction. Since this is simplified as far as it'll go, remember we're going to take the denominator, move it to the front, and then just eliminate it, basically this fraction leaving the top. So we're going to have 2a minus 1 for the first factor. And this is already reduced to a 2, so we don't have to do anything with that one. We'll just have a plus 2 for the second part. Okay? All right, let's look at number 10. Number 10. Again, I cannot pull anything out of these, in at least whole numbers. I can't pull anything out of those as factors of any of those terms there. So what we're going to have to do is we're going to have to do our A, B, and C. A is 9, B is 3, and C is negative 14. All right, let's create the X. And on the top, we're going to have 9 times a negative 14. A times C. It's going to give me negative 126. The bottom, we still have a 3 for B. And now we're going to have to look at the factors of 126 so that we can find out if something, the difference of those factors would make a 3. Okay? And I'm going to do this on a sticky note. I'm going to do this on a sticky note first. And then I'm going to show you something after we do this the normal way. We have 126, and we know that we can factor this into 1 and 126, 2 and 63. We have 3 and 42. Yep. And then, let's see here, 6 and 21. We can't do 7. Can we do 7? Yeah, we can do 7. 7 and 18. And then we've got 9 and 14. And that gets us about as far as we can. Don't have a 10, don't have 11. And 11 times 11 would be 121, and 12 times 12 is 144, so neither of those work. It looks like we may not have a factor or two factors that would have a difference of 3, but let me teach you a trick here. This is actually going to be not factorable. Not factorable. And let me teach you a trick on how to know when to stop factoring. Okay? College professor kind of showed us this little trick. You kind of see the pattern anyway, but he showed this little trick on the board, and it made a lot of sense. Whenever I have factors, if you'll notice, when we list them like this, as I go down this list, if I went to the next number that would be a factor, it would be 14. And let's just do this for a second, just for sake of the argument here. We're going to have the next factor would be a 14. Well, what's going to be the factor that goes to 14? 9. And then the next one would be 18, and that's going to be 7. So what's happening to my numbers? Well, just reversing, the products that we already knew. All right, so once you find, this is called, this is the middle, we'll say the mirror. When you find the mirror, you don't go any further. Okay, let me show you what I'm talking about here. If I had these factors again, if I'm doing it on number line, I have 1, 2, 3, 6, 7, and 9 going this way. When I have 14, 18, 21, 42, 63, and 126, they're going this way, right? And once I find this mirror line, they're just going to flip. They're just going to mirror and repeat each other, right? They're just going to repeat each other. And so once we find that middle or that mirror line, we can stop checking for factors because there's not going to be any more. They're just going to be the repeat of the ones we've already found in reverse order. Okay, so this one, number 10, is not factorable, and that's the only one that we're going to deal with that's not factorable today, at least. Let's move on. Let's do number 11. Number 11, can I factor something out of all of these terms? Yes. What can I factor out? I can factor out a 2 out of all 3. So I'm going to factor out a 2, and I'm going to have 10p squared plus 11p minus 6. And now at this point, I'm going to have to go to my x method because I can't do anything grouping-wise, and nothing factors out of each one of those again. So I'm going to have to go to my my x method, and I'm going to have to find out what my placeholders are here. So for A, I'm going to have 10. For B, I've got 11. For C, I have a negative 6. I'm going to draw the x. In the top, I'm going to put 10 times negative 6, which is a negative 60. In the bottom, I'm going to put the B, which is 11. And I need to find, because this is a negative, I need to find the difference that will become 11 of my factors that multiply to be 60. And I've got, if I'm getting close to 11, I need to start looking at, let's see, 6 times 10 doesn't work. They're 4 apart. I need something a little bigger. So what about 4 times 15? 4 and 15. Right, that would be 60. One of these has to be negative, and remember the rule, the bottom one determines the sign of the larger one. So if that's positive, that means the 4 has to be negative. Alright, so that being said, again, my A is not 1. Okay? My A is not 1. So that means when I create my binomial factors, I'm going to have P minus 4 over 10. And then P plus 15 over 10. Okay? And we also need to make sure we don't forget that we still have this 2 that we're going to have to bring down in the final answer. Well, if I reduce this fraction right here, or simplify this fraction, I end up with 2 over 5. If I reduce this one, I end up with, dividing both of them by 5, I end up with 3 over 2. Okay, that's the same thing. 3 over 2. And that's the simplified version. So I'm going to take my 5 out in front of the P, and I'm going to take my 2 out in front of the P on this one. Remembering, again, I've got to bring this 2 down from the top. So my final answer is going to be the 2 times 5P minus 2. And then I'm going to have 2P, 2 times the P, plus 3. And there is my completely factored form on number 11. Okay. Let's, just for sake of time here, and hopefully we can get this into one lesson, let's work one of the solving the equations down in the bottom. I feel like we can probably work through the rest of these on our own for practice if we want to. Let's look at number 16. Let's look at number 16 and see if we can get a solution for the number 16 problem here. The first thing we've got to do when we're trying to solve an equation is we've got to get everything equal to 0, so we have to put everything on one side. So I'm going to take and move the 16x across, and I'm going to move the 48 across. And when I do that, you know it's going to take and change the sign of both of them. So rewritten, I'm going to have x cubed plus 3x squared minus 16x minus 48, and then now the only thing left on this over here, this side is going to be a 0. Alright, and then I'm going to look at my groups. Okay, I'm going to look at my groups. Noticing again, I've got this negative sign right there. Okay, that's hopefully going to help us remind us to look for a negative out of both of those if we can. If I look at the groups here, I can take an x squared out of this first group. So I'm going to take x squared out. That leaves me with 1x there, and it leaves me with a 3. Okay, so I'm going to have x squared times x plus 3. Then, if I'm looking at this, I can pull a negative 16 out of both of those. Negative 16 can be taken out of the first term, leaving an x. Negative 16 can be taken out of 48, leaving me a positive 3. Again, this still all equals 0. Now I can take the common factor, this x plus 3, I can pull it out completely, x plus 3, and then I'm going to have x squared minus 16, and that still equals 0. But I'm not completely done yet. X squared minus 16 is a difference of squares. So I can factor it down even further. So I've got x plus 3 times x plus 4, x minus 4. And still all equal to 0. And then I can now set each one of my factors equal to 0 and find the values that make each factor equal 0. Find the x values. And so we know this already. We talked about it. All we have to do is take the opposite sign. When there's no coefficient in front of x, we can just take the opposite sign of each one of these numbers with x. So we have a negative 3. We have x equals a negative 4. And x equals a positive 4. That would be our solution set for number 16. A negative 3 would make this one become a 0. A negative 4 would make the second factor become 0. And a positive 4 would make the third factor become a 0. So my solutions would be negative 3, negative 4, and 4. Alright, and again, we could apply that to both of these other two, and we could solve them as well. But there's your 7.8 and 7.9 notes. Hope this has helped you guys. You should be able to make some pretty good headway on your practice, and we will work on that in class tomorrow. All right, you have a great day.